Hello and welcome back to the Coking.com YouTube channel. I'm Evan Hyde and I'm here in Germany at Berthold, and I'm here with Heike Mann, and she's going to be sharing with us some of the technology related to bulk flow and moisture measurement on the coker. So Heike, could you introduce yourself a little bit to our audience?
Thank you, Evan, for being here with us. And I'm Heike Mann, working for Berthold since 28 years now. Started in the R&D and I moved to sales and product management. In the meantime, I'm leading the product management group and the technical sales department at Berthold.
Thank you for that introduction. Well, I'm here to introduce something that I only learned about relatively recently in the world of delayed coking, and this is the ability to use nuclear radiometric instrumentation to measure what's coming out of the delayed coker, the back end, right?
Yeah,
this
that's
is
right.
What's happening on the solids. So what I'm used to seeing in this particular application is some sort of weigh bridge to measure the weight of the coke moving down the belt, and almost nothing to get moisture. So we'll talk about moisture in a minute. So how does your system, because I think most of our audience is familiar with the weigh bridge style, how does your system work? And
the radiometric bulk flow system works like you're used on for your coke drum. You mount a radiometric detector above the belt in this case. So here, Evan points to it, and below the belt you mount a radioactive source. And by using the absorption principle, you measure the amount of material flowing through or over the belt. And it's a contactless, very reliable measurement with close to no maintenance required. So you install it and basically forget about it.
so you have to do some calibration of every instrument, really, but you have to do some
correct.
calibration to this. And so what sort of information do you need to do the calibration to get this measurement? So I think you talked about speed, right?
Yes, the instrument requires a speed signal. This can be by a tachometer or by a known velocity the belt is running. So this can be given to the instrument by a current input, for example, or a pulse input. We also have that. And by measuring the area weight of the material on the belt, combined with this velocity signal, we can easily give the customer tonnage, meaning the mass flow.
Yeah, so you do this not only in delayed coking application, you do it in mining, you do it all sorts of solids handling.
Yes, absolutely.
It's maybe new to me and maybe new to our little ecosystem, but the rest of the world is very bought into this concept.
Yes, and they are happy customers using a radiometric bulk flow meter, they are happy that they buy it because it's amortized since within a very short time.
So we talk about, you mentioned in preparation for this that there are some customers that use it for custody of transfer.
Yes.
So normally have one level of accuracy and then you can actually go to a higher level of accuracy. So how accurate can this sensor get?
It can be as accurate as 0.5% tonnage, depending on the calibration. So you do have to do a reference weighing, but it can be as good as 0.5%.
So you can really dial it in. I mean, I think everybody in my world would be happy with plus or minus 1%, but 0.5%, that would be exceptional.
Yes. It takes quite a while to do a proper calibration, but if you have done that, it runs for years.
Yeah. And unlike the weigh bridge, it requires, periodic recertification, the strain gauges might go out of calibration periodically.
Yeah, this is not necessary with a radiometric gauge. From time to time, you have to do some cleaning because of the dust you face with the coke. But yeah,
just like in the coke drum, if you leave a little coke behind, it occludes the counts, and you can see our other videos where we talk about all that stuff. But you just got to make sure that it's nice and clean, and you'll get a good signal every time.
Correct.
Interesting.
And it's all available in stainless steel, so yeah.
And so that's for the bulk flow measurement. Now there's another technology which is on the opposite side of this little demo. What is this?
This is sensors to determine the moisture of the coke, for example, or the moisture of the material. We do not use it only for coke, you determine the moisture, and if you combine these two signals, the bulk flow meter and the moisture meter in your DCS, you can basically find out the dry substance of the coke.
Yeah. So I think this is something which is interesting to me because in the delayed coker, we're pretty good at figuring out how much feed comes to the unit, and we're pretty good at figuring out how much liquid and vapor products come out of the unit. The amount of material from a solids perspective that comes out of the unit is oftentimes people are like, I don't know. Like, maybe my weighbridge is accurate, maybe it's not, I don't really know.
Yeah.
And then it's still telling me some amount of material is flowing through it with moisture of unknown value, right?
Right.
So in terms of closing the material balance and sort of really understanding your yield and, trying to really dial in your process, this system enables you to really close that box in a way that I don't see very commonly in our unit.
It's not very known so far.
Yeah.
Not at least not in the cooking universe.
Well, we're going to fix that.
Good.
All right. So, but there's a little caveat with this moisture measurement that I think we need everybody to realize. So, like on the coke drum structure, the bulk flow measurement is area rated, right? So if we can do it on the coke drum, we can certainly do it on the belt. But unfortunately, this measurement is not area rated.
No,
right?
it's not. You need to make sure that you install it at the right spot.
Yeah. And I think that this is reasonably easily accomplished because usually the conveyor belt is leaving the unit and going into some open air environment that isn't necessarily area rated. And so you may have to think about, well, maybe I put the bulk flow sensor in
the area rated area, and
the moisture maybe 500 meters away in an unrated. You got to run some extra cabling or something like that, but it's pretty manageable. Or maybe you can do like a wireless or something like that. So interesting. So thanks, Heike.
Welcome.
I think this is an interesting technology. I'd like to see more of this out in the delay coker because as a process guy, closing the material balance actually has large value. And these two sensors help us to do that. So thank you for sharing this technology with us. We greatly appreciate it. And hopefully you enjoyed the video. And we'll see you in YouTube land for more delayed coking specific videos here on our channel. Thank you.
Thank you, Evan.